you. Prof, can you hear me? Can you hear me? Is it
Yes, sir.
okay? Okay, great. I need to change my screen. Let me see how do I do this. And is my video okay? Let me see.
Yes, it's visible.
Okay, my video is visible. Thank you very much. Good afternoon, everyone. I'm Dennis Khong from Multimedia UNC in Malaysia. Today I'll be talking about, I'll be having a short presentation on this question of should law students learn computer programming? In a way, Dr. Wayne's presentation preempted my this presentation. I think he have already essentially answered the question of yes. I hope to give a bit of more depth into this question. So let's have a look at how I've come to this question. So the motivation behind answering this question, there are a couple of 5 points I have noticed. Number one, starting from last year, somewhere in the middle of last year, I teach in a law faculty, and some law students requested for a workshop on legal technology because they read in the news, they follow Facebook and some other platforms, and they noticed that there's something new called legal technology, and they wanted a workshop. So I conducted a one-day workshop for my law students, and within that one-day workshop, we had an afternoon session on Python programming. So I thought it was going to be a very challenging session trying to teach law students programming, but it didn't turn out too badly. Some students after the session requested for more and says, why don't we think about having an elective subject? And I started this process of drafting this elective subject. In fact, I grouped in the students as partners in designing the subject. So instead of me thinking of what exactly they need to do, I said, okay, you go ahead, you have a first go first, and I'll come back, we'll discuss. So we have a subject in the pipeline. The second point, the second motivation is in recent years, starting from last year and a couple of years even before that, we start to see law firms, both in Malaysia and I've also seen in Singapore, law firms having spin-off. So the partners form legal technology companies. So in a way, what we are seeing is that law firms are not sitting ducks waiting for technology to overwhelm them and take over their job, but instead, what we are seeing is lawyers and law firms are actively entering into this space, this domain. And obviously, the natural question is, what are the skill sets that we need to train lawyers and law students in to anticipate for potential work within this law tech field? And that relates to the third question, or the third motivation, is we now also start to see law tech companies, these law tech companies, not just having technologies, IT people, programmers, but they also have legally trained people inside, and they have job titles such as legal knowledge engineer, legal data analyst. And again, coming back to these questions, well, if some, not all, some of our law students eventually become legal knowledge engineer, become legal data analyst, what are the skill sets, what are knowledge that we need to impart to them so that they can have a foothold into this career choice if they so decide not to become a practicing lawyer? Fourth point is we also start to see legal hackathons, both at the national level as well as international level. For example, there is annual global legal hackathon held in one weekend in February, and multiple locations around the world will organize hackathons based on local themes. And the idea is for both law people as well as technology people, as well as neither law nor technology people, to come together to flush out potential ideas of application of technology in legal field. So we see law tech, regulation, reg tech, and blockchains, legal blockchains, and so on. and they do minimum viable product MVP as well as demos and do a pitching. And from the national level, then what happens is usually they go to regional and international level to do pitching. And this year, because of COVID-19 pandemic, there was also an international online version of the Global Legal Hackathon where people from different cities, from different places can work together online and come up with a video pitch. Next, also we see an unfortunate phenomena of current batch of law students actually don't have any, if at all, coding literacy in schools. At least in my country, we only in recent years, this year and last year, there is talk about introducing computer programming, such elements of computer programming into formal education curriculum. But for the current generation of law students, they don't. Computer literacy, yes, they know how to use Microsoft Word, PowerPoints, they know how to use email, surf the web, databases, and so on. But in terms of actually writing programs, understanding, reading computer programs, there are not many. Probably a handful, one or two might have a bit of exposure, but not many do have any kind of exposure. And this is in a way a worrying trend. So with these 5 motivations as a background, so we started thinking about how should we design a course which includes elements of computer programming to law students. So we start with identifying the learning objectives. So obviously at the very onset, we declare that we are not going to train law students, law graduates into computer programmers. We are not going to turn the law school into an IT school. That is very obvious. But what do we want to do? We want to allow students to understand, to appreciate computer science concept at a deeper and more accurate level. Because traditionally, even sometimes when we teach subjects such as computer law, information technology law, cyber law, we tend to use analogies to explain technical concepts rather than really looking at how this technical concept really work at a coding level. So we want to achieve that at a more realistic level rather than talking in analogies like blockchains are like chains one after another and so on. Emails are like postcards. We don't want to talk about this at that kind of analogous level. A second learning objective is we want students to be able to use basic computer programming concepts such as variables, functions, conditions, loops, data files and to use them, to understand them, to understand the syntax and operation, as well as to be able to construct computer programs. I think this is a very important point. We are not, again, going to ask them to do a full-fledged commercial software. That is not the objective, but at least 10, 20 lines of code should be reasonable. Say, for example, how to read data from a file and do some manipulation operation on them, print them out, save them back into the file, and so on. Basic ideas, which is, I suppose, should be appreciable and doable for law students level. And with that, we also hope that they could learn how to read programs. Third objective is to learn more sophisticated topics such as machine learning, deep learning, natural language processing, contract review systems, document assembly. We think these are building blocks, right? So having some sort of computer programming knowledge will become building blocks, stepping stones to understanding a bit more sophisticated level. And if you choose a good and simple language, we could even let them try out some of these concepts and just have a proof of concept at that level. So we are not, again, moving away from analogous thinking into actual hands-on. Finally, we want our graduates to become intermediaries between traditional legal practitioners and legal technologists. lawyers have their vocabularies, they have their culture, they have their thinking, same as programmers. Programmers have their own language, have their own concept, they have own culture, and there is a need to bridge the two different fields so that when they communicate, there is common understanding between the two. So if we have law students, law graduates who both understand law as what the lawyers understand, and as well as can understand computer science concepts as what IT people could understand, then there is less cross-talking, using different language and thinking in the different concepts. So at least they could be act as an intermediary. And this also works back to what just engineer being one of the role that they play is actually between the data scientists, between the programmers at one hand and the traditional legal practitioners, and to be able to bridge the gap between these two fields. So a bit about potential computer programming languages. There are hundreds, if not thousands, of computer programming languages. So, digital computers started in the 1950s, and since 1950s, there are many computer programming languages, and each of them serve a different purpose. Each of them came about in a different context, in a different environment, technological context, the hardware during that time, what the capabilities of that time, as well as what computer science knowledge and understanding of that time. So language that has been developed today would be very different from language that is developed 20, 30 years ago, even though some fundamentals do remain the same. So with that, there is no single one best language. Each language has its strengths and weaknesses, and we do need to recognize the strengths and weaknesses of computer programming language. Rather than finding the best language, what we should do is we should find the best tool for the job. And with that in mind, we ask the question, now if we want to teach law students computer programming, what would be suitable languages, or at least one suitable language that we can use to achieve that 4 learning objectives? We do take into account there are trends into programming languages. Languages comes and go. In the 70s, 80s, basic programming was in vogue. Logo was in vogue. Then later on came Pascal. C at the time was very influential. C is still very useful today, but typically at application level, people tend not to use C anymore, but it goes still very much use C at a lower basic level where they need to access and have a very fast computation processors. So what languages are trending now? If you look at charts, there are lots of different sources of charts based on different data, some based on questionnaire, others based on contribution of number of codes in public repositories or codes. So what is trending now? Languages such as JavaScript, Java is still there. Java is still very much used for Android programming. C is still there for a lot of system programs are there. Python is a favorite for data science, machine learning. PHP is for web, and R is also very popular among the data science community. Some of these languages are free as in both free to access and modify in the codes, as well as free as if there's no need to pay for any of free to use as well. We don't need to pay for license to use. On the other hand, there are also not free languages or not free implementation of languages. These are commercially available. One of the more famous one is MATLAB. People using MATLAB will have to pay a license for MATLAB. So how do we find an introductory programming languages? So what we did was we looked at, or what I did was I looked at the literature. Daphne, in the paper 2014, identified 4 main criteria to identify introductory programming language. It must be ease of use, it must be easy to use. There is textbook and teaching material, because we are thinking not for programmers for programmers' sake, but rather for teaching purpose. So there must be textbook, there must be teaching material. there must be a good programming environment. For example, what we call IDE, Integrated Development Environment, where the coding, the execution, the debugging can all be done in the same platform, same software. So that makes programming easy rather than having a text file and then they need to use command to compile, to execute programs and so on. As well as cost, obviously free is better than have to pay. And at cash-strapped universities nowadays, to ask universities to pay a couple of $100,000 a year for licenses to a lab of computer softwares will be very expensive, and they always ask and say, is there a free implementation? Can you find something free which is as good? Gupta 2004 identified six of them, and they are very much similar to what Daphne has identified. Simplicity, ease of use, orthogonality, that this is there's this certain philosophy in certain programming community. There's this philosophy that you should use a language which not only allows you to do one thing in many ways. You should have a language which there's an obvious, easy, natural way to do certain things. And so that is what he means by orthogonality, one obvious way. Identify the target audience, and in our target audience would be students. So naturally, students, you need to have a teaching and textbooks. Coverage, one of the things that talks about coverage is which operating system does it run on. Obviously, the majority of students will be using Windows, but we still also have students who are using Macs and Linux, and we also need to think about the system also work on that platform. Regularity, that is the question in relation to, is it a dead language? Do the people still upgrade and improve on it? What about if there are bugs in the language, in the compiler, in the interpreter? Are they being reviewed and patched and upgraded? So you want a language is still very actively being developed, and there's improvement along the way. Turnaround time and debugging, how difficult is it to debug and use a language that is that turnaround time and debugging support. Parker, Cho, Ottawa, Chang, 2006, reviewed 60 literature. So obviously it's not just these two, Daphne and Gupta. There are many other papers has been written identifying programming languages. Some of them, they analyze one particular language, and he reviewed 60 literature and identified 23 further criteria for selecting an introductory programming language. So what did we find? We identified two possible candidates, Python and R. Each of them has their strength. We find both Python and R will satisfy the two sets of criteria that Daphne Gupta has also identified. So let me just quickly run into Python. So Python was introduced by Guido van Rossum in 1990. Currently, it is at version 3.83, and it's still been actively updated. It's interpretive, it's considered top language, and it's been used to develop software, backend system, websites, and so on. It is very easy to use and very important. I'm sure Wayne will support me on this. It has extensible to advanced AI applications, machine learning, deep learning, natural language processing. Everything is there, and it's such a big ecosystem. There are 241,273 projects at the Python package index, and they are, apart from PyPy, there are also packages outside of this ecosystem. So you can easily imagine it's a very big community contributing lots of code. So many of the functions we need is already, someone has already done that. We can pick it up, improve on it, and so on. R was first developed by Rose Ikata and Robert Gentleman from the University of Auckland in 1993. Currently, it's version 4.01, and just like Python, very frequently updated. In 1 year, there are a couple of updates, both minor updates, usually minor updates. Rarely they do a major update, but as you can see, 4.01, there was a major update in very, very recently this year. R actually is a statistical programming language. In a way, it started off as for statistics by statistics, for statisticians by statisticians, because it was an implementation of as statistical programming language, but S wasn't free, it was a commercial language. So Rose and Robert, R&R, decided they want a free S, because if you had, since it was S was commercial, every little implementation they wanted in S, they had to wait and beg the the company which owns S to implement it for them. See, they say, why wait for them? Let's design one where it is free and everyone could extend it and implement functions that is not there. Just like Python is interpretive, but the underlying components are actually compiled, so it's not pure interpretive. And there are ways of actually do what we call just-in-time compilation. So you compile everything into bytecodes and run it at a slightly faster pace. It's mainly used for statistical, data science, machine learning community. It's less compared to Python. It's less used for full-fledged software packages. There is web framework, so they could create mini websites, which is largely to design graphs and processing data and so on. There is currently 15,000 over packages on the comprehensive R archive network website trend. So from that, we have identified two potential candidates for languages. So we think about a syllabus. So these are what some of the topics we thought which will go into a computer programming for lawyers or law students subject. We should start teaching them with flowcharting, so draw diagrams first. Like diagramming will teach them how to think in steps. Variables, assignment, how to do mathematical operations. These are simple computer programming languages as a calculator. Then we move on to functions, how to use function as well as how to make your own user-defined functions. Conditions obviously are very important because branching the computer programs have to decide is it A or is it B, and then if it's A, what to do, if B is what to do. Loops, because there's a lot of repetition, processing, and so on is necessary. Data structures, apart from just single variables of containing numerals and strings, they are complex data structures. So we have to talk about arrays, lists, data frames, and so on. Input, output of files, data files, how to download, load file, plug it into data frame, process it. Once you have got the data, clean it up. Once you save it back, how to do the output. We are thinking of we also need to talk about graphics and statistics. So if you're talking about both R and Python has very strong statistics and statistical graph. So, and we are thinking maybe some old style logo, turtle, move 20 steps, turn left, turn right stuff. And we use that from what we have already done as a starting step to show some implementation of AI, machine learning, example, logistic regression, support vector machines, SVM, and so on. So this is something what we think is achievable within 1 semester, 13, 14 weeks time frame with 2-3 hours of hands-on session, lab session. So that's all for my presentations. Thank you very much. I would like to take some questions if you don't mind.
Thank you very much, sir. So since seeing that we have no questions on the platform right now,